Okay, so if you're a developer, you already know Git is basically the king, right? It's how we manage our code. But it has this one huge Achilles heel, and that's what we're going to talk about.
Yeah, I'm willing to bet this hits a little too close to home for a lot of you. You know the feeling. You're deep in your workflow, the code is just coming together, and then, bam! You've got to commit a big file. Maybe it's a 3D model, a high-res image, whatever. And your whole process just slows to a crawl. That's the frustration we're going to unpack today.
So what's the deal here? Well, Git is an absolute wizard when it comes to code, right? Because code is just text. It can look in two versions of a file and see exactly what changed, line by line. But binary files, totally different story. Think of them as these big black boxes of data. Git can't peek inside and see the tiny differences in a new version of a PNG. So what does it do? It has to save the entire new file every single time. And that right there is where the trouble starts.
And this quote really gets to the heart of the problem. Every time you tweak and commit, say a 100 megabyte file, Git doesn't just save your little tweak. Nope, it saves another full 100 megabyte copy of that file. Imagine doing that just a handful of times, your repository size just explodes.
All right, so let's officially call it what it is. Git's big file problem. And it's super common, affecting way more projects than you'd think. It really boils down to two main things. First, you've just got a project that's been around forever, with a super long history. All those tiny commits, they just add up over time. But the real problem, the thing that puts things into overdrive, is the second cause, large binary files. We're talking design assets, big data sets for machine learning, game assets. This stuff can make your repo an absolute nightmare to work with, fast.
Okay, so before we talk about the slick, modern solution, I think it's kind of fun to look back at how we used to deal with this. For years, developers had to get creative with these clever, but let's be honest, pretty clunky workarounds.
And that's the key thing to remember here. These were band-aids, not cures. A shallow clone is definitely faster. Yeah, because it only grabs the latest history. But what happens when you actually need to see something from 2 years ago? And filter branch? Oh man, that thing is like performing surgery on your project. It's powerful, but it's also dangerous. It rewrites history, which means everyone on your team has to reclone the entire project. So yeah, they helped, but they didn't really solve anything.
Check this out. This is a perfect real-world example. The folks over at Atlassian timed a full clone of their Jira repo. Now this thing had an 11-year history, and it took 4 minutes and 24 seconds just to get the code on your machine. Ouch.
Now, using that shallow clone workaround we talked about, the time plummets to under 30 seconds. I mean, that's a massive improvement. But again, it's a workaround. It's awesome for things like a build server that only needs the latest code. But for a developer who needs to dig through the history, it's just not going to work. We needed something way better.
And that something better finally arrived. So let's meet the hero of our story, Git LFS, which stands for Large File Storage. It's this awesome open-source extension for Git built for one reason and one reason only, to solve this exact problem.
Okay, so here's the magic trick. Instead of stuffing that huge file into your Git history, Git LFS does something brilliant. It swaps it out for a tiny little text file. And this text file is just a pointer. It's a little note that basically says, "Psst, the real big file, it's over there."
The idea itself is so simple, but the way it works is just genius. So let's take a look at how this whole pointer system actually works in your daily workflow.
So when you go to clone a repo that's using LFS, you're not actually downloading every single version of every massive file from the dawn of time. You're just getting the code and all these little, lightweight pointer files. And that means your initial clone is lightning fast and your local repo stays nice and small.
So where are the actual big files? Well, they live on a completely separate, dedicated LFS server, and they only get downloaded to your computer when you check out a version of the project that actually needs them. It's basically a download-on-demand system, which is just so much more efficient.
All right, so let's tie this all together. Why is this whole pointer system the definitive, hands-down best solution to Git's big file problem?
Well, the benefits are huge. Clone times get absolutely slashed. Your local hard drive isn't getting chewed up by giant files you aren't even looking at. You can actually version your large assets properly without slowing Git to a crawl. And maybe the best part? Your code and your big assets can finally live together in the same place, in perfect harmony.
You know, this has been a total game changer, especially for teams that have both developers and creative pros. Before LFS, designers, video editors, or CAD users, they were stuck using something totally separate like Dropbox or Google Drive to share their files. Now, they can jump right into the same Git workflow as the developers. It's amazing.
And that really brings us to the big picture here. Git LFS isn't just some technical fix. It's a tool that enables better collaboration. It tears down the walls that used to exist between technical and creative teams. So the real question I want to leave you with is this. When your tools finally stop getting in the way, what incredible new things can we all build together?